Okay, good day. As of today, alam nyo na yung Terzaghi'S bearing capacity or Terzaghi'S equation to find the soil bearing capacity. Okay, so many researchers try to improve the theory of Terzaghi in finding the soil bearing capacity. Okay, so this has a modification of Terzaghi's bearing capacity. So after the development of Terzaghi's bearing capacity equation, several investigators work in this area and redefine the solution. So this is Mayer Hoff in 1951 and 1963, si Landgren or Mortensen in 1953, Bala in 1962, Vesic in 1973, and Hansen on 1970. So different solutions show that the bearing capacity factors NC and Q do not change that much. Okay. However, for a given value of sigma prime, the values of the value of n obtained by different investigator vary widely. Okay. It should be, I think it should be n gamma. This one. I think it should be n gamma. Okay. So for a given value of phi, okay, or phi prime, the values of n gamma obtained by different investigator vary widely. So in other words, yung NC and NQ is hindi ganon malayo sa factors provided by the bearing factors provided by Terzaghi. However, for n gamma factors, it shows a different values. Okay, vary widely. So this difference is because of the variation of the assumption of the wedge of the shape of soil located directly below the footing. So as explained in the following graph, the angle alpha shown in the failure wedge, okay, is much closer to 45 plus phi prime over 2 than to the phi prime as was originally observed by Terzaghi. So if we go back to sa failure wedge, okay, so let us open yung failure wedge in shown in Terzaghi bearing capacity. If we go back this one, yung failure wedge na tinutukoy nila is this yung triangular wedge shape zone at mark 1, and this one is yung mark 1. Okay. So according to them, yung angle alpha at this failure wedge 1, yung alpha is within this one. Dito, yung angle na to is much closer to 45 plus phi over 2 than to phi prime as was originally observed by Terzaghi. Okay, therefore, they provided the new bearing capacity factors. So this one is based on Reisner in 1924, Prandtl in 1921, and Vesic in 1973. So this was for NQ, NC, and N gamma. For NQ, the bearing capacity factor for NQ is tangent squared 45 plus phi over 2 e raised to phi tangent phi. For NC, based from Prandtl equation in 1921, NC is equals to your NQ solved from Reisner equation minus 1 multiplied by cotangent phi. And from Vesic equation, your N gamma is equals to NQ minus 1 tangent to 1.4 times phi. So if you don't have a calculator that can solve for this one, you also have the new bearing capacity factors based on the equation by Reisner, by Prandtl, and by Vesic. Okay, so 5.14 for sigma, that is for phi prime, that is equals to 0. Okay, so let us try to check. Try natin mag-check. Okay. So let us try checking 12 degrees. Okay, let us try checking 12 degrees. Okay, sige. So first, doon muna tayo sa NQ. So NQ, that is tangent 45 plus, lagay ko muna siya ng x over 2. Okay, then squared multiplied by e raised to phi tangent x. Okay, your calculator should be in degrees since yung 45 is in degrees. Okay, 45 plus 45 degrees plus phi over 2. So therefore your phi must be in degrees. Okay, so let us try 12 degrees. So solve 12 degrees. Okay, so that is equivalent to 2.97. Okay, let us try 14 degrees, this one. So try natin yung 14 degrees. So calculate 14 degrees, still have 3.59, which is also correct. Okay, try naman natin tong 50 degrees. Okay, so by 50 degrees, calculate 50. That is equivalent to 319.057. Okay, so then solve natin yung NQ minus 1 cotangent phi. Okay, so NQ, okay, so your NQ minus 1, cotangent is 1 over tangent. So divided by tangent, your degrees, ilagay na lang natin ng D. Okay, so let us try for 12 degrees. So calculate, okay. Okay, alpha, yan, sorry, should be shift. Okay, so calculate your N, for 12 degrees, your NQ now is 2.97. Okay, then your D in degrees is 12. Okay, so you have 9.268 or 9.27. So 9.28 siguro yan if we try to provide the exact value of NQ. Okay, so still lead to the same answer. Calculate 3.59 for 14 degrees. Then your angle is 14. 10.37. So maybe that is 10.37 if we provide NQ, the exact value of your NQ. Then for 50 degrees, okay, your NQ is 319.07 and your angle in degrees is 50. So that is 266.89. Okay, so they are the same. Okay. So for N gamma, no need to, if you want to check, you can try these factors, okay, using this equation by Vesic. Okay, so using this modified bearing factors, okay, the soil bearing capacity equation for a strip footing given by Terzaghi can be modified for general use by incorporating the following factors. Okay, so if you recall the equation for strip footing provided by the Terzaghi's equation is CNC QNQ plus 0.5 gamma B and gamma, or 1/2 gamma B and gamma. So according to the modified Terzaghi's bearing capacity, we can use the formula of the strip footing provided by Terzaghi to different bearing capacity of foundation, okay, of shallow foundation. Meron lang siyang factors na incorporating the factors they provided. Number 1 is yung depth factor, number 2 is the shape factor, and number 3 is the inclination factor. Okay, so again, we call this one as the general formula for the modified Terzaghi bearing capacity. Okay, so for depth factor, this is to account for the shearing resistance developed along the failure surface in soil above the base of the footing. The shape factor is to determine the bearing capacity of a rectangular and circular footings, and inclination factor is to determine the bearing capacity of a footing on which the direction of the load application is inclined at a certain angle to the vertical. Okay, so therefore, the modified general ultimate bearing capacity equation can be written as this one. So mapapansin nyo, CNC plus QNQ 1/2 gamma B and gamma. So galing siya sa strip footing equation ni Terzaghi. So they provided this what you call this one, shape factor. This one, FQS. Okay, FQS. Okay, sorry. This one is for shape factor. Ito shape factor. This one is for shape factor. This one is for depth factor, depth factor, depth factor. This one is for inclination factor, inclination factor, and inclination factor. Okay. Your C prime is cohesion. Your Q is effective stress at the level of the bottom of the foundation, just like what I said for Q. Your gamma is the unit weight of the soil, and B is the width of the foundation or the diameter of a circular foundation. So we can also use gamma B. If you recall yung binigay ko sa inyong steps to determine gamma B. So this is the unit, that is the effective stress at the level, at the B distance level from the bottom of the footing, without including the effective stress at the top. Okay, nag-start ka dun sa effective stress at the bottom of your footing. So that is already your gamma B by the effect of the groundwater table. Okay, then your FCS, your FQS, and F gamma S is the shape factors. FCD, FQD, and F gamma D are the depth factors. FCI, FQI, F gamma I is the load inclination factors. NC, NQ, and gamma are the bearing capacity factors from the equation of Reisner, Prandtl, and Vesic. Okay? So para hindi kayo malito kung ano yung factors, yung mga shape, depth, and load inclination factors. So check nyo lang ito. Yung subscript C stands for the cohesion equation. So yung may cohesion equation, yung may subscript na Q stands for the term with Q and Q, this one. And the subscript N gamma, F gamma is from the third term, which has a unit weight of the soil, yung may gamma in this one. Okay, then the subscript S stands for the shape, the subscript D stands for the depth, and the subscript I stands for the inclination. Okay, so kung gusto nyo ng shape, lagyan nyo lang ng S lahat. Kung gusto nyo ng depth, lagyan nyo na lang ng depth lahat. Okay? Kung gusto nyo ng inclination, lagyan nyo lang ng I lahat. Okay? So yan lang yung para hindi kayo malito for the new factors. Okay, so how to solve for the shape factors, the depth factors, and the load inclination factors. Okay, so let us consider now the shape factor. So according to D. Beer in 1970, so ito siya, kasama siya sa mga nag-try to modify the Terzaghi. So according to D. Beer in 1970, the shape factor is given by this equation. FCS is equals to 1 plus B over L and Q over NC. Your FQS is equals to 1 plus B over L tangent phi prime. And your F gamma S is equals to 1 minus 0.4 B over L. Whereas your L is equals to the length of the foundation and L is greater than B. Okay? So yun yung length of your foundation. So for example, ang dinedesign mo is this one. Okay. So ito yung B mo and dapat yung B mo is less than your L. Okay, yung L yung mas malaki. Yung L is away from your monitor or away from your monitor. So yan yung ito yung B, ito yung L, and ito yung column. Okay? So take note that your L should be greater than B. Okay? Then for the depth factor, you have condition A and condition B. Condition A is when your df over B or your depth of foundation, okay, depth of foundation is this one. So ito yung ground, this is your depth of foundation. So condition A is when your depth of foundation divided by the width B or the ratio of your depth to width B is less than or equal to 1. Okay, so meaning mas malaki yung width B compared to the depth of your foundation. Okay, yung D sub F. Okay, your FCD is equals to 1 plus 0.4 df over B, and your FQD is 1 plus 2 tangent phi prime multiplied by 1 minus sine phi prime squared multiplied by df over B, and your F gamma D is equals to 1. And condition B is when your df over B is greater than 1. So this time, your depth of the foundation is much greater than the width of your foundation. Okay, your FCD is equals to 1 plus 0.4 tangent inverse of your df over B. Take note that your tangent inverse of df over B should be in radians, since your df and B have a unit, and this is basically practical distances, df over B. Therefore, it should be in radians. Okay. Your FQD is equals to 1 plus 2 tangent phi prime 1 minus sine squared tangent inverse of df over B. And your F gamma D is equals to 1. Okay. So for inclination factors, this comes from Mayer-Hoff 1963 and Hanna and Mayer-Hoff in 1981. Okay, your FCI is equals to your FQI, that is equals to 1 minus beta over 90 squared. Beta in degrees divided by 90 degrees squared. Okay, your F gamma I is equals to 1 minus beta over sigma prime squared. Okay, your beta is the angle, the inclination of the load on the foundation with respect to the vertical. So for example, I have a load na pa ganito. Okay, I have an axial load P. So kapag meron kang axial load P or basically a straight axial load or axial compression P, so the angle from horizontal from vertical is your beta is equals to 0. Okay? However, if you have an inclination, okay, so paano kung may inclination yung load mo? Let's say this one. This is your P. This will be your angle beta. Okay? So, for undrained condition, so if your footing is subjected to a vertical loading, that is when your beta is equals to 0, then, so for undrained condition, meaning your phi is equals to 0. And your cohesion is equals to C sub U, and your N gamma is equals to 0 if you try to check the equation for N gamma. Okay, try to check your equation for N gamma, you will come up to 0. Your NQ will come up to 1, and your NC will come up to 5.14. So if you can already check this one for phi that is equals to 0. Okay, so this is your phi that is equals to 0. Okay. So there, if you try to check the inclination factor using this condition, your FCI, your FQI, and F gamma is equals to 1. So this will be equal to 1 when your vertical loading beta is equals to 0. When your vertical loading beta is equals to 0, this will cancel out, and this will also cancel out. So what will be your inclination factor is will all be equal to 1. Okay, so okay, so take note again that your tangent inverse df over v should be in radian, and this shape factor are empirical relationship based on the extensive laboratory tests by these different sources. So si D. Beer, si Hansen, si Meyerhoff, and si Hanna and Meyerhoff. Okay, yung based on their research. Okay, so let us try an example problem. So this comes from the book of Das and Sivakugan in 2017. So a square footing is shown in figure 12.5. So this is our figure. So determine the safe gross load, having a factor of safety of 3 that the footing can carry using this equation. Okay, so never mind the equation number. So we will discuss this one. So our figure or our square footing has a width of 1.2 by 1.2. Okay, yung foundation natin is 1.2 by 1.2. So your groundwater table is located 0.5 meters from the ground level, and you have a vertical load. Okay, then also your total depth of foundation is 1 meter from the NGL. Okay, your gamma is 16 kilonewton per cubic meter. Your C prime is equals to 0. Cohesion is equals to 0. Your phi prime is 32 degrees, and your gamma sat is equals to 19.5 kilonewton per cubic meter. So let us try to solve for this problem. Okay, so using the equation of modified Terzaghi, okay, so this equation 12.9. So according to this equation, we need to find C and C, FCS, the shape factor, okay, the depth factor and the inclination factor, your Q, your NQ, your gamma B, and your N gamma. Okay, so let us try this equation. Okay, then according to the problem, your cohesion is equals to 0. Therefore, this first term will cancel out. So kapag C prime is equals to 0, your only equations is the second and third term. So therefore, we have this equation. QNQ, FQS, FQD, that's 1/2 gamma B, and gamma F gamma S and F gamma D. So nawala na rin yung lahat ng may cohesion. Okay, lahat ng may F cohesion na shape factor. So ito cohesion ng may factor. Okay. So nawala ito. Okay. So also nawala rin yung ito. Nawala ito. And this one. Okay, lahat ng may cohesion nawala. Okay. So that is why meron na lang tayong factor N, FQS, FQD, FQI. So F gamma S, F gamma D, and F gamma I. Then also take note guys that we have a vertical loading. So meron tayong vertical loading. So if you remember, if you have a vertical loading, your beta is equals to 0. Therefore, your FCI, your FQI, and your F gamma I is equals to 1. And what you have left is this equation only. Okay, this equation only. Okay, so nawala na yung factor na 1 dito. May 1 pa dyan, then dito 1. So nawala na yan since puro 1 lang naman siya. Okay. So I remember during my college days, we need to memorize this all factors, yung modified Terzaghi'S bearing capacity. So we need to memorize that one. Okay, so checking the bearing factors NQ and N gamma using a phi that is 32 degrees. So let us check. We have a phi that is 32 degrees. Okay, your phi is 32 degrees. So this one. So therefore, we have 35.49 NC, 23.18 NQ, 30.22 N gamma. So NQ and N gamma na yung need natin. So 23.18 and 30.22. So 23.18 and 30.22. Okay? So let us solve the shape factor. So unahin natin yung shape factor. So unahin natin to and ito. Okay, so the shape factor FQS, according to the table, your FQS is equals to 1 plus B over L tangent phi prime, and your F gamma S is 1 minus 0.4 B over L. Okay, since our footing has a 1.2 by 1.2 meter width, okay, therefore your FQS is 1 plus B over L tangent phi, that is 1 plus 1.2 over 1.2 tangent 32, that is 1.625. And your F gamma S is 1 minus 0.4 B over L, that is 1 minus 0.4, 1.2 over 1.2, you have 0.6. Okay, then we need to find the depth factors, this one and this one. So check natin yung depth factors. So what do you think is our condition? Okay, your DF is equals to 1 meters and your B is equals to 1.2 meters. So your DF over B is equals to 1 over 1.2. That is obviously less than 1.0. Therefore, this is case A. And under case A, your depth factor FQD is equals to this equation, and your F gamma D is equals to 1. Okay, so that is why your FQD is equals to this equation, so which is equals to 1 plus 2 tangent 32, 1 minus sine 32 squared multiplied by DF over B, you have 1.23. And your F gamma D is equals to 1. Okay, then we need to find your Q. Okay, so solve na rin natin yung Q. Tayo na yung mag-solve dito. So our Q is basically the effective stress at this point, this level. Your Q is equals to, okay, 16 times 0.5, tama ba? Multiply by, plus the saturated unit weight minus the unit weight of water multiplied by 0.5 meters. Okay, therefore your Q is equals to, okay, your Q is equals to, so 16 times 0.5 plus 19.5 minus 9.81 times 0.5. That is equals to 12.845. Okay, so if you go back, that is equivalent to 12.845 kilonewton per square meter. Okay, then we need to find this gamma B. Okay, hanapin natin yung gamma B na yan. So according to what I told you for gamma B, so let us find this B distance. Okay, our B distance is equivalent to 1.2. Okay, so we need to find the effective stress at this point, and this will be our gamma B. Therefore, your gamma B is equals to, what is this effective stress at this point? This point, that is equivalent to gamma sat, which is 19.5, minus the unit weight of water multiplied by the distance B, which is 1.2. That is equivalent to, okay, let us try. That is equivalent to, that is equivalent to 19.5 minus 9.81 multiplied by 1.2. That is equals to 11.628. So that is equivalent to 11.628. Okay, so let us check if we all have the parameters, or we all have the datas. We have your Q, we have your NQ, the shape factor FQS, and the depth factor FQD. Your gamma B is okay, your N gamma is okay, the shape factor F gamma S and the depth factor F gamma is also okay. Okay, so therefore, we can now solve for ultimate bearing capacity Q sub U. So 12.848, 23.18, 1.625 times 1.23 plus 1 half. Again, this is your gamma. Okay, so this is your gamma B. The same. This is your gamma B. That is 30.22. That multiplied by 0.6 times 1. You have 700.54 kilonewton per square meter. Okay, so according to the problem, the problem is asking what is the safe gross load using a factor of safety that is 3. So your Q allowable is equals to your QU divided by Fs. So meaning your bearing capacity divided by the factor of safety, that is your allowable. Okay, so your Q allowable is equals to QU ultimate divided by a factor of safety. So therefore, 700.54 divided by 3, that is equals to 233.51. You have 3 times factor of safety. So you will only allow this much stress in your soil. Okay, so meron kang room for error, kumbaga. Okay, so to determine the load, basically, your stress is equals to force times area, di ba? Your stress is equals to force over area. So to determine the force, that is equals to the stress times area. Okay, so therefore, your stress is, let's say, denote as Q, or your point load or your actual load is equals to denoted as large Q, and your stress is equals to the Q allowable, yung inallow mo for your design, which is your QU over Fs, multiplied by the area of your foundation. The area of your foundation is B squared. So therefore, that is equivalent to 233, okay, 233.51 multiplied by 1.2 by 1.2, you will come up to approximately 336 kilonewton. Okay, so this will be your allowable or the safe gross load with a factor of safety of 3. Okay, so any more questions regarding this modified Terzaghi'S bearing capacity? Okay, so if you have question, please message me on Blackboard. Okay, so my question is when to use modified Terzaghi'S bearing capacity or the original Terzaghi'S bearing capacity. So in your exam, I will take note what equations you were going to use. If you I indicated using the modified Terzaghi'S bearing capacity, you will use this the equations in given in this module 14. Then if the problem as using the Terzaghi'S bearing capacity, walang word na modified, you will use the equations provided by module 13. Okay, so if you have question, please message us on Blackboard or message in our messenger group. Okay, so thank you.